The Sun is the closest star to Earth, located approximately 93 million miles away. It is a middle-aged star, estimated to be about 4.6 billion years old. The Sun's diameter is about 109 times that of Earth, making it a relatively large star. Its mass is approximately 330,000 times that of Earth. The Sun's energy comes from nuclear fusion reactions, primarily converting hydrogen into helium in its core. It has a surface temperature of about 5,500 degrees Celsius, 9,932 degrees Fahrenheit. The Sun's outer atmosphere, the corona, can reach temperatures of millions of degrees Celsius. Sunspots are cooler, darker regions on the Sun's surface caused by magnetic activity. Solar flares are sudden releases of energy in the Sun's atmosphere, accompanied by bursts of radiation. The solar wind is a stream of charged particles flowing outward from the Sun into the solar system. Solar eclipses occur when the Moon passes between the Sun and Earth, blocking the Sun's light partially or completely. The Sun is composed mainly of hydrogen, about 74%, and helium, about 24% by mass. Solar energy powers Earth's climate, weather systems, and photosynthesis in plants. The Sun rotates on its axis, completing one rotation approximately every 25-35 days. Sunlight takes about 8 minutes and 20 seconds to reach Earth. The Sun's gravity holds the solar system together, keeping planets and other objects in orbit around it. The Sun's magnetic field undergoes an 11-year cycle of activity, known as the solar cycle. Solar maximum and solar minimum are phases of the solar cycle characterized by increased or decreased sunspot activity and solar flares. The Sun will eventually exhaust its hydrogen fuel and evolve into a red giant, engulfing the inner planets, including Earth. Solar energy can be harnessed through solar panels to generate electricity. The Sun's energy output is relatively stable, with variations of about 0.1% over the solar cycle. Solar energy is a renewable and clean source of power, offering potential solutions to mitigate climate change and reduce dependence on fossil fuels. The Sun's atmosphere consists of several layers, including the photosphere, chromosphere, and corona. Solar telescopes, such as the Solar Dynamics Observatory, SDO, study the Sun's activity and structure in detail. Solar storms, such as coronal mass ejections, CMEs, can disrupt satellite communications and power grids on Earth. The Sun's magnetic field extends throughout the solar system in the form of the heliosphere. Solar observation spacecraft, like the Parker Solar Probe, study the Sun up close, exploring its outer atmosphere and magnetic fields. Solar prominences are large, bright features extending from the Sun's surface into the corona, often associated with magnetic activity. The Sun emits energy across the electromagnetic spectrum, including visible light, ultraviolet radiation, and X-rays. Solar energy drives the Earth's water cycle, powering evaporation, precipitation, and weather patterns. The Sun's gravity influences the orbits of planets, moons, asteroids, and comets in the solar system. Solar neutrinos are subatomic particles produced by nuclear reactions in the Sun's core, providing insight into solar processes.